everybody. Today we're going to be doing some two-column proofs. Now, given that AC is congruent to EC and BC is congruent to DC, I want to prove these two triangles congruent. Now, how do we do that? Using two-column proofs. Well, our first step in a two-column proof is always going to be our given statement. So we're going to write AC is congruent to EC and BC is congruent to DC, and our reason for that is given. Now, for our next step, what else can we prove about these two triangles? What other parts of the triangles are congruent? Well, we can prove that angle ACB is congruent to angle DCE. And why? Because vertical angles are congruent. And finally, our last step, we have a side, we have an angle, and we have a side that's congruent on both of the triangles. So using the SAS postulate, we can say that triangle ABC is congruent to triangle EDC. Alright, now this problem might be a little bit confusing, so please pause the video and try to find out the solution to this one. Well, what can we say about these two triangles, given that all of this information? What can we prove first? And obviously we put our given statement first, and then what? Well, we have a side, AB is congruent to EF. We have an angle, angle BAD is congruent to FEH. And we have another side, AD is congruent to EH. And because BAD and FEH are the included angles, the angle in between the two sides, we can use the SAS postulate to state that triangle BAD is congruent to triangle FEH. Now, why is this important? Why do we have to prove this big triangle congruent? Well, the reason why we have to prove this big triangle congruent is because now we can state that angle ADB is congruent to angle EHF because corresponding parts of congruent triangles are congruent, or CPCTC if you want to write it the shortcut way. So if two triangles are congruent, then all their corresponding parts, the angles and the sides, they're also congruent. And now you could take a look at what we did. We proved that this angle is congruent to the other angle. And when we take a look at this tiny triangle, so triangle EHG and triangle ADC, what we can see is that we can use the SAS postulate to prove that these two triangles are congruent, because AD is congruent to EH, that's one side. CD is congruent to GH, that's another side. And the angle we just proved congruent, so EHF and ADB, those are congruent, and that's the included angle. So we could say that triangle ADC is congruent to triangle EHG because of SAS. And our last step, proving that AC is congruent to EG, all we got to do is just use CPCTC again. Now, I'm not even going to lie, these problems can be really annoying sometimes, but with enough time and practice, you'll get used to a lot of the patterns that these problems have. So it's okay if you might be confused at first. On to the next problem. Now, this problem, once again, you can feel free to pause the video and try to find out the solution. Well, once again, we start off with our given statement. So angle 1 is congruent to angle 2, is congruent to angle 3, and EN is congruent to DG. Now you see how we have this isosceles triangle, so triangle MED is isosceles triangle because it has two angles that are congruent, so angle 1 and angle 2. Well, we can also say that ME is congruent to MD. Those sides are congruent because in a isosceles triangle, if two angles of the triangle are congruent, then the sides opposite to those angles are congruent. Now, our goal right here is to try to somehow prove that the big triangles, so triangle MEN is congruent to triangle DMG, because if we prove those two triangles congruent, then we can use CPCTC to prove that angle 4 is congruent to angle 5. And one trick that kind of helped me understand this problem a bit better is I took out the triangles from the diagram. So we're gonna kind of take out triangle MEN and triangle DMG and then get them side by side so we could see which parts are congruent and which parts we can prove that can be congruent. So we already have one side, which is ME is congruent to MD, and we have an angle because angle 1 is congruent to angle 3. And we have this other side, EN is congruent to DG. And you see how, once again, we have side, angle, side, SAS. So we could say that triangle MEN is congruent to triangle DMG because of SAS. And then our final step, we could use CPCTC to say that angle 4 is congruent to angle 5. And I hope y'all enjoy the video. Happy New Year's and have a nice day.